Hello. Oh. Oh, hi everybody. How are you guys doing? Whoa. My voice is traveling crazy right now. Sorry, this is insane. Cool. All you, I think. Wait, where does it project from? Hmm? I plugged in something. Let me turn this off. You guys don't hear this.
Do you have Hi, everyone. Sophia began her career as a deployment engineer and analyst at GM, where she transitioned into software engineering role, observing real-time LLM-based robotic systems on the plant floor. Now, as a developer advocate at Elastic, she draws on her experience optimizing and troubleshooting logs, traces, and metrics in high-stakes in-plant production high-stakes environments. She brings both technical depth and practical insight to the challenges of observability at scale. Please help welcome Sophia.
Testing, testing. Oh, awesome. Great. Nice to see everybody here. I don't know, I'm excited to share this talk with you, and thank you so much for coming, even though I don't know anyone here, except for the people I've met. So I appreciate you guys. But yeah, good afternoon. Thank you for coming to my talk. How has everyone been enjoying Linux Fest so far? It's good? Yeah? Yeah. That's awesome. That's awesome. Well, as my tech support introduced me, I'm Sophia, and honestly, I'm so excited and truly a little bit nervous because this is my first conference talk ever. Thank you. I'm happy to be doing it here at Linux Fest, which I've heard from other people, not even in Texas, that it's the best conference ever. So I'm glad to be here. And even though I'm super nervous, we're going to talk about something a little scarier, debugging LLM applications. But don't worry, by the end of this talk, you'll know how to move from reactive grepping and grep-based panic to proactive observability. But first, let me kind of paint you a picture. So imagine it's 3 a.m. or maybe some other equally inconvenient time, and your LLM application is down. Actually, let me pause. Can you raise your hand if you've had to debug something at kind of an awful time? Can I get a show of hands? Right, okay. I'm in the right audience. This is the right space for this then. Great. So to continue, your LLM application is down. Users are coming to you left and right, complaining about long wait times. So you do what we've all done. You open a terminal and start grepping. The top grep command in that, off green box will find errors in your app log. The next one will find timeouts. The next one will grab the tail of any app log for user 123. But grep here, it doesn't scale. There's no real-time insights. There's no correlation between LLM events. But before we go further into solutions, I'll tell you a little bit about my journey Again, I'm currently a developer advocate at Elastic. I actually started like 3 months ago so this is really new to me and I'm really excited. But I'm passionate about making observability accessible to absolutely everybody. Like the main reason is because of how much I've struggled in my previous Grep-based roles and debugging. Like in my last position, we were initially setting up our observability solution. I remember consistently going back to the terminal window, typing in the password, and of course, you can't see the password, so if I right-click, maybe sometimes it doesn't show up there, and I don't copy it right, so I have to copy it again. And then grepping through logs to pull issues for my team. So my mission today with this talk is to show you the better way to understand your LLM applications. Modern observability solutions have capabilities that are far beyond anything Grep can hope to accomplish. This will help everyone move from, again, reactive grepping into proactive monitoring. So let me go over a little bit of what we're covered today. Oh, I skipped a slide, but I went back. Here's our roadmap for the next, what time is it? I guess half hour or so. First, we're going to dig into why traditional logging fails for LLM applications. I know everyone can basically have a guess, but yeah. And then we'll introduce modern observability. What is it and why it works? Finally, we'll go into like more practical implementation. How can you get started observing your applications this week? And then I guess if there's time, we'll save a few minutes at the end for questions. I'd love to hear them. And even if I can't answer them all, I will still listen and answer them at a later time. So let's start with the problem. Why are LLM apps so hard to observe? LLM applications are different from any of the traditional web applications in so many fundamental ways. They're uniquely complex, unlike traditional apps. There are many caveats that differ nowadays. There are non-deterministic outputs. Gone are the days of predictability, as there can be several different answers for even the same output, for the same input. So response times, they can vary wildly from 100 milliseconds to even 30 seconds, super long. Every request costs money in tokens, real money. What is that money and where is it going? What does it look like? You might be using GPT-4, Claude, Llama, all in the same app. All of these make multiple API calls per request. Where are those going? How many API calls are being made? I mean, look at this app architecture. There could be data pipelines, there could be app hosting, there's orchestration, there's framework, there's embedding models, there's context data stores, there's agents, APIs, plugins, and then even in the LLM side, there's logging, monitoring, LLM caches, validation, and guardrails. Each one of these things needs to be monitored so that our system can be consistent and also safe. So how would you even grep through all of this? I mean, the answer is you can't. So let's move on to an actual scenario that relates to this. Imagine it's Tuesday afternoon. You get a Slack message. Hey, the AI feels slow today. Okay, great. So you need to figure it out. Is it actually slow for everyone? Which model? Why? What model was used? What was the actual response time? How many tokens were consumed? Was this user session context large? Were there any retries? What were other users experiencing? With traditional logging, here's what you try to do. You grep for the user ID, you grep for their session, and you try to piece together the timeline. 30 to 60 minutes later, you might have the beginnings of an answer, beginnings of a root cause. But this is why traditional logging fails. We're not looking for reactive grepping. We're looking for proactive solutions that we can act on in real time, because that's where all our apps lie, in real time. So, more on traditional logging fails. As I said, it can take 30 to 60 minutes minimum to find a root cause. Data logs for LLMs can exceed 10 gigabytes, and honestly, that's on the conservative side. And Grep's memory just gets exhausted. It's like me actually trying to run a 5K. It's not gonna work. Like, I'll get down the street, maybe. And the worst part is that there's zero proactive insights. You only know what's wrong when users tell you it's wrong. Traditional logging was designed for deterministic, synchronous applications, and LLMs are neither. So let me show you what this actually looks like in practice, the Grep struggle. So this is what we try to do, right? We try to find slow requests. We, like, these are actual commands that I've run. Obviously, there's no user ID, like ABC123, but these are very generic examples of the requests that I've run before. And these commands can get complex fast. I mean, look at this mess. To find slow requests, I need awk, I need pipes, I need word count. To correlate by user, I mean, good luck. And this is all just for one question. Is the LLM slow today for this one user? What if I wanted to compare models, track costs, or see trends? None of this works at scale. I mean, we've all written commands like this, right? That's not taking. That's not working on a wide scale. It's really small. But I promise there's a better way. That's when we enter modern observability. I didn't hear the keynote this morning, and I heard there was a really good breathing exercise, but I don't know what it is. So I'm just gonna breathe real quick. Okay, we're good. So yeah, there's a better way. We've established the problem. Grep doesn't cut it for our LLM applications. But the good news is that modern observability does solve all of this. I mean, what if you could understand your entire system in seconds instead of hours? And that's what I've built today. I have a little code repo. I'm gonna post it on LinkedIn like maybe 2 weeks from now, and that's when you can kind of get into it and see it. But I'll go through kind of the things that I used to build it and everything, and then we'll keep it going. So I would like to introduce you, though, to the 3 pillars of modern observability. But actually, can I ask, does anyone know the pillars of observability? Anybody? Hands? Oh, in the back?
Metrics, events, logs, and traces.
Right. That is one more than I have, but I like events. It's good. It's good. But yeah, no, that's right. So these are the 3 pillars of observability. There's metrics. Metrics are quantitative data. They're numbers over time. They're like your heart rate monitor at the hospital. These are things like response time, error rate, request rate, token consumption. Next are logs. I like to call logs the backbone of observability, because that's kind of where we all start. That's where all of our data kind of lives. But these are structured logs. They have contextual events. They're not just random text screens. They have events with context and metadata. Examples are like detailed error messages, like user actions, and system state changes. And lastly, there are traces. This is the story of a request. It's the flow and timing across services. From start to finish, across them all. I mean, this is where you see where time is spent. And all three of these together give you complete visibility. Metrics show you what, the traces show you where, and the logs show you why. But although we know all this, and they can all exist in their own bubble, there's a thing that makes modern observability so much more powerful than traditional logging. I mean, let's compare the old school versus the new school. Traditional logging, it's unstructured. There's unstructured text strings. Each log is independent. It's isolated. It's reactive. You look when something breaks. Each log line is just in its own bubble. But on the right, we have modern observability. There's structured data. Everything is correlated. You're watching dashboards proactively. You can query across dimensions. You see relationships between services. The key word here is structured and correlated. That's what makes modern observability work at scale. So now that we know all this, we know the differences between traditional logging and modern observability, we know why Grep doesn't work. How do we get there? How do we start observing our own systems? That's where OpenTelemetry comes in. So OpenTelemetry is kind of like the hero of our story. OpenTelemetry, or OTel, for people in the know, which is now everybody in this room, is the industry standard for observability. It's backed by the Cloud Native Computing Foundation, or CNCF. That means it's supported by Google, Microsoft, Amazon, and pretty much everyone who has a stake in this modern technological environment. And honestly, here's why it's awesome. It's vendor neutral. You're not locked into any single tool. You can change backends, observability backends, as fast as you can change pants. So not very fast, but you know, kind of a little bit. There's automatic instrumentation for popular frameworks. It works in 11 plus programming languages, and that's conservative. And it's battle tested. Companies at massive scale are using OpenTelemetry in production. With OpenTelemetry, you can instrument once and send it anywhere. That's the power of it. You add OpenTelemetry to your code, and you can send data to literally any backend. So let me show you how it works. First, I'll go over a basic diagram, and then we'll kind of get into like steps that OpenTelemetry kind of follows. So this is how OpenTelemetry works in practice. You start with your application. Could be JavaScript, could be TypeScript, Python, any language. You install the OpenTelemetry SDK, which automatically captures traces, metrics, and logs, sending them via OTLP, which I'll go over later as well, to the OpenTelemetry collector. The collector receives, processes, and batches this telemetry data. Then you can export it to the backend of your choice. Could be Elastic. That's it. No, I'm just kidding. Could be anything else. Could be Prometheus, Datadog, Jaeger, any system that speaks OTLP. And your application code, it doesn't change, just a configuration. So these are the 3 steps to get started. It's kind of what I said in the last slide, but I'll just go over it again. First, you install the SDK. I mean, it's just a pip install. Can barely see that. Sorry about that. Oh my gosh. First, you just do the pip install. That says OpenTelemetry-API/OpenTelemetry-SDK. And I will make that brighter for my next presentation. There are both automatic and manual options available. Step 2, OTel automatically collects telemetry data. It's collected and actually enriched. Traces are enriched with spans. Each operation gets a span. To explain, a span is a single atomic operation or unit of work within a distributed trace. It has a name, a start time, a duration, and may include attributes, such as key value pairs, that provide additional context. Spans are then linked together, typically in a parent-child relationship, to form a complete trace, which visualizes the end-to-end flow of a request through your distributed system. Next, metrics can be enriched with labels. You can slice and dice them, and they allow for filtering, grouping, and aggregating metrics based on specific characteristics. And lastly, logs can be enriched with context. They're tied to traces, and if there are any additional structured information attached to a log entry, it can provide more detail about the event actually being logged. So I guess this is where events comes in. Thank you so much. And then step 3, you can export it to the back end of your choice. Again, as I mentioned before, there are so many options. Elastic. Others, right. Today, as I mentioned, I will show Elastic, but there really are others. And as I'm sure there's people from all these companies sitting in this room right now and might watch it later. So you guys are valid, I promise. And I won't get bogged down in the details yet, but I'll show you what the code actually looks like, transforming from traditional logging into OpenTelemetry-based observability. So this is what we used to do. It's traditional, it's pretty standard stuff. We log the user query, we time it, we can log the result. But notice, I mean, these are just strings. There's no structure, there's no correlation. There's no way to query this efficiently. And when something goes wrong, honestly, you're back to grepping. So yeah. But now here's the same code with OpenTelemetry added in. I mean, check out how much better this is. I'll give you a minute, not a minute, I'll give you a couple seconds to look at it. There's the same functionality, but I mean, look at the difference. We create a span, that's our trace. We add attributes. It's structured data that we can query. Attributes such as model name, query length, token count. And the timing is automatic. There's no manual time, parentheses even needed. And honestly, here's the magic. This span is automatically correlated with the parent request. And all of this is queryable in real time across millions of requests. But we need somewhere to send this data, or it's just not going anywhere. So that's why I want to introduce you to my demo architecture. I don't actually have my demo up for today. I'm keeping with slides, but again, in a couple weeks, feel free to check it out on my GitHub, Sophia-solo. Awesome. But let me just walk you through. Is this a pointer? No, it's not. There's no pointer. No, okay. Tech support. Let me just walk you through how this architecture works. It all starts in that top left-hand corner. A user interacts with our chat interface through their browser. They ask a question to our LLM application. That HTTP request hits our Flask application running on port 5000. I'm running on port 5000 because it was a local instance. Of course, there's so many ports that you can run from. Now, inside of our Flask app, we have several layers working together. First, we have the routes handler process, which processes the incoming requests. It handles chat, it handles metrics, it handles logs, and all the endpoints. Then, this is the real key for modern observability. It's the OpenTelemetry SDK. This can automatically instrument our code, capturing traces for timing, metrics for performance, and it's doing almost all of this. It's doing all of this with almost zero code changes. Below that, we have our LLM integration layer. It can be Hugging Face, it could be Mistral, or any simulation that you're trying to run. And notice at the bottom, we still have our traditional logging to a file. That's our phase 1 logging solution. It's the old way that we're evolving from. Now, this is where modern observability really begins, in the OTLP export. Our telemetry data flows directly from the Flask app to this OTLP export layer. OTLP, aka the Open Telemetry Protocol, is the key. It's a vendor-neutral standard. Our application speaks OTLP and OTLP only. It doesn't care what's on the receiving end. Meanwhile, all our old school log files are being shipped by FileBeat. This shows the transition from phase 1 to phase 2. Everything flows after that into our observability backend. Now, again, I'm using Elasticsearch and Kibana here, but you can use anything, and it's completely swappable. Because we're using OpenTelemetry and OTLP, I can replace it with Prometheus, Grafana, literally anything that speaks OTLP. And my application code won't change, not one bit. The instrumentation stays the same. The protocol stays the same. Only the destination changes. It's just a configuration update. For this demo, Elastic handles all 3 pillars really well. Elasticsearch will store our traces, metrics, and logs, and Kibana will give you the visualization layer. We could make dashboards, do discover for logs, APM for traces, and it's all in one UI. We get powerful querying and analysis capabilities, but remember, this is one option among many. You could use any self-hosted or enterprise observability backend that you need to use. Whatever fits your code, your needs and budget, and your code. At Elastic, a lot of the times we like to say, it depends. And I think that's really true here. Whatever your code is, it depends on what you, whatever your code is, it depends on like what you can use. You know what I'm saying? Oh no, that was a bad sentence. I'm moving on. Again, that's the beauty of OpenTelemetry. You can instrument it once and send it anywhere. Your observability backend becomes a configuration choice, not a code commitment. You're never locked in, and that's what's truly powerful. So now that we know all this, we know OpenTelemetry, we know why Grep doesn't work, we know modern observability, what exactly are we even tracking for LLM applications? I mean, I'm sure there's a lot of different options, but I chose to focus in on 3 kind of big areas. For LLM apps, we care about these 3 categories. First of all, there's performance. Is it fast? What are the P50, P95, P99 latencies? What's the time to first token? How long until the response actually starts? What are the tokens per second? I mean, what's the throughput? And next is the cost. I mean, how much is this costing us? What is the cost per request? Which users or models are the most expensive? What's the model usage distribution? What are the peak usage times? And lastly, there's quality and errors. I mean, is it working? What are the error rates? What are the retry patterns? Are we hitting rate limits? These are your questions your boss might ask. These are questions you can ask yourself in the mirror about your application. But now you can answer these in real time without worrying about grepping through an awful log. And let me show you the true before and after of instrumenting OpenTelemetry. This is before, and this is fine. It's grep-based debugging. It's painful. You you can put out a command that will find all the requests for this user ABC123. And then you can find requests that took over 2 seconds. And obviously you have this verbose grep command. And it gives you individual log instances. Again, these are strings. I mean, I love copy and paste as much as the next girl, but I mean, that's just painful. Next, you can find all the logs for this specific user's session. And again, it just gets longer and longer. You can grep for that ID. You can then parse the timestamps manually, and you can find errors around the slow request. This is not great. But there's a transformation that can be made with modern observability tools. Whoa, crazy dashboard. This is the modern observability dashboard. There's so many parts that go into this. You can get the number of responses over the last hour, the real-time chart. There's average request duration, there's types of questions asked. You can get success and error rates, like visual gauges for it. You can get user usage and response trends. I mean, how often is a user actually using this service? You can have model performance comparisons. Which one has actually been used the most? And here's the kicker. 3 seconds. All of these questions can be answered in 3 seconds when looking at this dashboard. Not 30 minutes, not hours. And past this, you can do really sophisticated analyses with it. And here are a couple of the ones that I was thinking of, where your data really transforms and turns more into proactive alerting than just wondering what's going on with my application. I mean, all of these questions are answerable now. Which models perform best for different query types? How does response quality correlate with your token count? What's the cost per user segment? Which models work best for technical queries versus creative ones? Does spending more tokens lead to better responses? Which customer segments are the most expensive? And all of these questions are not only relevant for developers debugging, but also relevant for any business insights. And all of these queries would be impossible with grep. I mean, maybe not impossible, but 6 months? I don't know. The problem's going to be gone by then, guys. But with the structured data, it's a 5-second query. And you can be proactive with your alerting as well. Instead of reacting to your problems, you can prevent them. You can get performance alerts. Is your P95 latency above 5 seconds? You can get a Slack notification before any users complain. Are there if the request rate drops below 50%, if the error rate is above 5%, then you can also get cost alerts. Token usage spikes, you can know immediately. You can see if the cost threshold has been exceeded, and you can see unusual model distribution. And then you can also get quality alerts. Are retry rates climbing? Something's wrong with one of your models. Is the model just completely unavailable? Is no one using it right now? Or is no one able to use it right now? Is the rate limit approaching? You can switch models proactively instead of waiting until that rate limit has been hit and passed. This is a shift from reactive to proactive. And honestly, it helps you sleep better at night. Helps me sleep better at night. So how do you actually get started with modern observability tools and implementing them? I mean, I know this seems like a lot, and I know I've been talking for a while, but getting started is actually fairly easy. First of all, you can install OpenTelemetry. It's usually just a couple packages. It's pip install OpenTelemetry API, OpenTelemetry SDK. Then you can choose a backend. I recommend starting with the free tier. Most of observability backends nowadays have free tiers that you can use, especially for your personal projects or just to prove out a concept to your company. You can evaluate these different backends based on your needs. Step 3, you can configure the export. At that point, it's just environment variables. You have service name, endpoint, done. And seriously, for an application, you can have basic observability in under an hour. This is critical. And honestly, there's an even easier way to start than going this way. There's automatic instrumentation. This is the magic part. You can do zero code instrumentation. If you're using popular frameworks such as Flask, Django, Express, OTel can automatically instrument them. I mean, watch this. You can install the packages, you can run your bootstrap, and then you can wrap your app start command. That's it. Now you have traces and metrics. There's no code changes at all. You can have observability today, seriously. And I know this relates to us being developers and developing our own applications, but there's also really big business impacts through this. Let's talk about what this means for your business. Problems that took you hours can now take minutes because there can be cost reduction because you can see where the money is being wasted. There can be fewer production issues because you can catch them before they're issues. The query speed, I mean, you can go from hours of grepping to seconds of dashboards. There's faster issue resolution. We as developers can spend less time debugging and more time actually building. There's better user experiences through these performance insights. This is about business value, and it's not just tech as well. And although this is amazing for your business value, there are a lot of common pitfalls that you can fall into when starting up your modern observability solutions. And these are just like a couple that I've run into and that I've seen other people run into. So let's learn from others' mistakes, namely mine. There's too much data. Don't log full prompts. I mean, you can, but they're huge and expensive. Try to truncate or hash them and try to log metadata. Avoid not sampling. Again, 100% trace collection gets expensive fast. There's lots of different ways you can sample. There's head-based sampling, there's tail-based sampling, there's different combined models. Again, it depends. Whatever your application needs, you'll find those needs and you'll be able to instrument them in that way. And then you're saving them time and money. I mean, here's what you need to do instead of all of those don'ts. You need to start with auto instrumentation. I mean, it's free. It's super simple. You don't have to pay anything. Then try to add custom spans for LLM calls specifically. Try to track tokens as a metric. And this is critical for cost. I mean, never log full prompts or responses, of course. Don't wait until after launch. Instrument early so you can make sure that you're observing your system from the beginning. And guys, don't make dashboards that you never look at. I mean, it's there, you know? And honestly, these are just tips. I'm not trying to lecture you. Obviously, everyone's applications are different. So past this, what can you expect kind of in terms of timeline? What can you do in the next few weeks to get more familiar with observability? You can try to clone my demo repo. You can play with it. Again, I'll be posting that in about like 2 weeks. You can try OpenTelemetry locally. You can see how it works. You can browse different backends and find the one that you like. This is just exploration. There's no pressure here. And then this month, try to pick one service that's not instrumented and instrument it. Literally choose the simplest one you can. Try to add OpenTelemetry to it. Create one dashboard that answers one question. Set up one alert and show your team the value. There are some resources that can help you get started with OTel that include OpenTelemetry.io. The Python SDK docs are absolutely excellent, and I'm not saying that because I've refactored a couple of them. CNCF also has free training for observability, including an OTel-specific training course. There are also so many amazing people working in the CNCF Slack. Just give them a ping, and I absolutely know they'll be able to help you. So in the end, when it comes to observability, the best time to start was yesterday, but the second best time is today. Again, just to end out, thank you all so much for being here. Thank you. thank you. I know that I've thrown a lot at you, and I hear myself, but I hope the main message is clear. Traditional logging doesn't work for modern LLM apps. OpenTelemetry is a standard that makes your observability portable. You can choose any backend that fits your needs, and getting started is easier than you think. And yeah, that's all. Thank you for coming. If anyone has any questions, I guess I have 3 minutes. I will take them in. Yes?
I've used
I want to say absolutely. But also, I would need to do more research about that. I just built a really simple Flask application, and I'm learning more about OpenTelemetry. That's really what's cool about it. You can just learn more and more and more. So I could definitely get back to you. You have my contact info. Yeah, so hit me up. But yeah, does that help? I don't know, slightly.
So I'll bug you about it as you build your solution.
Please, please, please. Yeah, any more questions? Oh, in the back, yes.
Yeah, just kind of, are you guys starting to look at OTel and especially for your developers to start to make better judgments about some of the LLM models that they're using? So in other words, if you get the right response with say a Llama 8 billion parameter, it's a heck of a lot faster and easier than a Llama 70 billion parameter.
Mm-hmm.
And true observability would be able to see that. So are you guys looking at the bigger picture and saying, wait, a developer always wants more? 70 billion is better than 8 billion?
Yeah.
But at the end of the day, if you're getting the right response without, any of the normal things,
Yeah.
are you guys looking at trying to have your observability system do that?
I think, are you specifically talking like at Elastic or like with like OpenTelemetry and all that?
I'm just at Elastic.
At Elastic, yeah. So I'm learning also more about Elastic in the observability space. I would love to take that question back since I am a developer advocate and kind of get more of a response to you. But I think that any solution can be tailored to what is best for your data. Maybe 70 billion is important in some instances versus 8 billion, right? But again, you have my contact info. Please give me a ring. Yeah, and that's time. So thank you. Thank you for coming. Thank you.